Good stuff.
Okay, so yeah, so I'm just going to talk about testing and especially testing things that have side effects or lots of side effects. So I'll run through this again for the sake of the video. So here is a very stupid game. It basically you just enter 3 valid integers in a row and then the game is over. So if I do 1, 2, and then if I enter something that can't be parsed as an integer, it'll throw an error. 1, 1, 1, and the game is over. So that's it. So it relies on 2 major side affecting things, getting input from the user, from the console, and then also printing to the console. But it's basically impossible to properly test those things. And so if you just go about this, let's say naively, you basically have a whole bunch of stuff that you can't test, which is not good. So one way to get around that is to use something called dependency injection. So rather than just having input statements everywhere all over the place in your class, you pull side effects into one place. So that's the first thing you do. You look at everything that does a side effect and you try to just pull it out. You can't eliminate it, but you can pull it out and try to just put it in one place. So anything that needs input is gonna be right here. So none of these other. So this is a pure function. It just takes something, parses it, and returns it. It's actually not technically pure because it could throw an error, but and then is game over is just gonna return a boolean. Add to guesses is gonna append something and then return that list. And then display message, this is also going to do a side effect, but I'm using dependency injection. So I'm going to have to supply a function to this, and it's going to call it. Yeah, this is not ideal, but we'll ignore that for now. And then I have a run function, which just executes everything under normal conditions. Okay. So now this should basically be totally testable. So one thing I can do is so some people were, when you're writing tic-tac-toe, you kind of want to like, okay, I want to make sure this way, if I do 3 x's vertically, then the game is over. So you have to manually do that on the console, right? You have to manually enter a bunch of stuff and then have to check for a tie. And how do you check for a tie? So you spend all this time kind of running through the game in the console. But if you design things with tests in mind, then you can just immediately change the state. So if for example, I want to test if the game is over when there are 3 or more objects in this, I just create the instance and then I immediately give it the state that I want to test. And then I can call the relevant method directly, is game over, which checks the length of self.guesses. So if I want to check the game is over with this, I can also check it with like 2 elements and it should be false, etc. So it's just very easy to immediately change the state to the specific thing that you want to test rather than having to manually run through everything. The other thing is valid input. So I create an instance of the class, and then I'm using this self.assert raises. So you could see when I entered something that wasn't parsable as an integer, it throws an exception, which is value error. So here, what I'm saying is I'm testing this, and I'm expecting this error to be thrown. So this is how you do that. You with assert raises, and then you pass in the error that you're expecting, in this case, a value error. And then you call the function, and this cannot get parsed as an integer, so it throws an error, and the test passes. So I'm just going to run this test real quick, just to show. So these tests pass. If I pass in something that can be parsed as an integer, like 3, it should throw an error. And by throw an error, I mean the test will fail because this did not throw an error. Okay. And then here is the more interesting case here where we want to test get input, and get input is, involves side effects, right? So get input, naively or normally, we're going to use the built-in Python input, which will get input from the console. But here, because we're using dependency injection, when we test it, we can supply our own function right there. So we're creating an instance of guesser, and then instead of using the built-in input function, which is the default here, we just pass in our own function and we can control what it does. So we're just going to say, essentially, this is a function that takes one parameter, just like input does, right? You provided a string, and then it is going to return something, which is a string. So we can just have our own dummy function here that fits that slot, takes in something and returns a string. Takes a string, returns a string. And this is going to directly return whatever this is. In this case, it's just going to be there. So now we can write an assert statement here. So that's the basic idea. It's a little odd, and it feels weird because you're kind of doing this indirectly, but there are some other benefits. So for example, what if instead of getting user input from the console, now we want to make an API call? So we want to get information from server somewhere. Well, instead of passing an input, now we can have another function that we write called, get input from HTTP server or something. And the basic logic should be exactly the same. You just pass in a different function depending on what you're doing. So now this is more general. Any questions about that?
When you approach the problem, you want it to take in 3 inputs. Are you writing the program before you're writing the test, or are you thinking about all of your edge cases and writing tests for all potential edge cases before you even start coding?
Yeah, so there is such a thing as test-driven development. This is like an official way of programming programming methodology, which is, it's actually part of extreme program. It's something called extreme programming. So, and it is extreme, right? You can imagine anytime you write something, you write tests first and then you write the code. So it's test first, test-driven development. You definitely don't have to do that, but when you do that, especially when you write lots of tests, whether it's before or during or after, you definitely have to think about how you design your code differently. You're constantly looking at your code from the outside, so from this different perspective, and so it definitely impacts your design decisions, because when you're just thinking about it as, oh, I'm going to write code, then I'm going to kind of run it manually and do some ad hoc stuff. Like, for example, this problem of input just doesn't matter, right? It doesn't matter if you have input state, you have huge functions with 5 different input things in different places and blah, blah, blah. It doesn't matter. But it actually does. You're preventing your code from being tested when you do that. So that's a little different than thinking about edge cases, but it's similar in that it allows things to be testable in the first place. And for the stuff that we're doing, obviously the stakes are very low. We're all just learning, but once you're on the job and things are, there's lots of money at stake and things are in production and lots of users depending on something, you have to test. You have to test things. So writing untestable code is just not an option. I don't know if that answered your question. It's kind of talking around some things.
Yeah, yeah, it's just hard. It's very difficult to implement tests when you're just focusing on solving a problem, right? Like our goal was to complete tic-tac-toe and just get it working, and we got it like 95% done, but we didn't really have time to write tests because it's like we're deep in the weeds trying to just get things to work, you
Yeah,
know?
yeah, exactly. So yeah, testing definitely takes more time. So it takes more time to develop, but over the long run, what really takes a lot of time is code that's difficult to maintain or that's buggy or whatever. So you know, if you're just trying to get something up right now as quick as possible, then yeah, writing tests is gonna hinder that. But if you want something, over the long term, having tests makes you waste less time. And another thing it does is it kind of forces you to think more about like the core structure. So, for example, what's the really important like when you're developing this and you're like writing code as you're doing things, you're kind of thinking about it like as the user. So I'm going to run the console and do some stuff and get an output, and then I'm going to write some code and blah blah blah. But you're not really taking a step back and thinking about what's the core element here. And the core element is going to be something like whatever data structure you're using to do this, and then the logic for determining the state of the game. And you can do all of that independently of any of the like input handling and printing stuff to the console and blah blah blah. So you can really solidly develop the core components of the system, and then after that's done, and that should all be like thoroughly testable. And then after that's done, it's like, okay, how do I display this stuff to the user or get user input or whatever? Okay. Um, yeah. So good job. And again, I realize that uh, I'm not expecting like you guys to have in 2 hours or whatever to have written a full test suite and blah blah blah. I understand how it works. I'm just trying to emphasize the importance of this kind of thing, which nobody wants to write tests, right? Nobody wants to do it, uh, but it's you just have to do it.
Would it be appropriate if maybe we just like out of the group just assign one person to just do tests and they just hop down that rabbit hole and just start writing tests while everybody else starts to look at the problem a little bit more detailed?
Yeah, I mean, you definitely could do that. Some tests, I mean, you also have an issue where tests in themselves are not like going to solve every problem you have, and you can definitely write tests badly or tests that are fragile, for example. If you haven't really decided on the core logic of the system or the like how you're actually going to represent this as a data structure and all that stuff, then writing a bunch of tests which are maybe more fragile or like cover like specific or easily changeable things. There's also a danger there. So yeah, it's a balance. I would say start with some simple core things, and then go from there. So I don't think you have to like have a full absolute fully specked out thing and then just write 30 tests and then go ahead and start developing it. But this is, I mean, this is a problem with front end testing in particular, where like if you want to test that, this button is at this particular position, or this bar is this color or whatever, you can write a whole bunch of tests for that. But then, once once the color palette changes, then you have to go and update all these tests, or something happens and the button gets shifted over somewhere else. So front end tests tend to be fragile like that. So you want to try and focus your effort on core stuff that's not going to change very often. All right. Any other comments or questions? Stop.